You know that expression, everything I needed to know I learned in kindergarten? Okay, well, I claim everything you need to know if you become engineers, computer scientists, mathematicians, technicians, etc., you learned in GIV. It really is true. This is not end-of-week fluff. There are surveys out there now that look at what we teach the kids and then what they end up actually using. Nothing I say should be construed to mean that the mathematics you would learn here is unimportant. Nothing I say should be construed to mean that learning how to solve partial differential equations is unimportant, or the microscopic elements of metallurgy, etc. But there's more than that, and when it turns out there's actual data now, survey data, that asks people who took an engineering education, what did you learn, what was emphasized in college, and what do you use outside of college? And one of the things that's leading to a gradual revolution in the curriculum at UVM is the discovery that those two don't overlap a whole hell of a lot. On the other hand, what people say they use as practicing engineers in the real world overlaps, it turns out, a huge amount with what you just did this week. And I'm going to just read a little list of all the things that I'm confident every one of you experienced this week, which turn out to be the major facets of what you do as a practicing engineer, applied scientist, mathematician, etc. In no particular order. Dealing with not enough time and not enough resources and getting it done anyway. Every one of you said, you know, if only I had one more day, or, you know, the PVC, if it was 2.5 inches in diameter instead of 1.5, tough, do it anyway, suck it up, make something great. That's absolutely standard. You're going to experience that all your life. You started learning it here this week. Get used to it. Globalization. The world is flat. The teams of engineers, applied scientists that you work with when you're out practicing will not just be in your company, your town, your country, maybe not even just your planet, but certainly it will be global. And most of you have experienced here this week working with people who don't come from where you come from, and discovered that this often used word, diversity, which has become sort of like motherhood and apple pie, important, but everybody says, yeah. Maybe you've discovered that if you're working with people whose background is different from yours, whose experience is different, who have different stories to tell, when they approach a problem, they're going to approach it differently. So a creative hand that comes from one place might have 3 fingers on it. A creative hand that comes from many places might have 20. So I hope you noticed that this week. It's going to turn out to be important. Virtually all of you discovered the interactive nature of design, the iterative nature of design. If you think that it's only novices who start here, go to there, discover what they did wrong, back up 2 steps, go ahead, get totally new ideas, start over, etc., that goes on constantly everywhere among the most practiced professionals in the world. So the iterative, back and forth, up and down, curly nature of design that you found this week, you got it. That's the way it's going to be. Dealing with trade-offs. I want my coffee cup opener to be small, strong, quick to use, cheap, safe, etc., etc., etc. I'm just picking a group that I work with. Guess what? You can't have them all. Or maybe you can have them all, but only if you're willing to spend a lot of money or have the customer spend a lot of money. Trade-offs are inevitable. Nothing will be perfect. Mother Nature applies all her rules all the time. The marketplace applies all its rules all the time. And you've got to live with all of that, and they always conflict. So if you notice that this week, remember it, because you're going to discover it again. I'll save that one for last. Materials, tools. Many of you said in your presentations today that one of the things you learned was how to use tools, how stuff behaves and feels. Fasteners of every kind. You learned that the entire world could be built from zip ties, or from duct tape, or from copper rivets. You came to understand how stiff a piece of wood is that looks kind of like that, and why it's stiffer this way than that way. So that hands-on understanding of nature and the technological world that you picked up this week, you go right on learning that, and you'll discover that's possibly as important as anything else. Making use of a limited menu of materials and components. Nobody gets to design from every catalog in the world. Nobody gets to custom make a molecule when you need it. Typically, in the real world, you go to catalogs. Nowadays, they're entirely on the web. But you select from a large but finite palette of stuff. All of you, in one way or another, had to do that this week. You might have wished for something else, but this is what was available, this is what was economically feasible, and you figured out how to use it. It's a little bit like traditional jazz, like Dixieland music. The rules are very tight, the creativity lies in doing something brilliant and new within the limits imposed on you. And finally, I used to have a colleague, Woody Flowers was his name, is his name, at MIT, who would tell groups of students working in teams, any sentence that begins with, "It's not my responsibility to," is false before you finish the sentence. It doesn't matter whether you're the team's electrical engineer, computer scientist, mechanical engineer, materials specialist, programmer, etc. When you are in the group mode, you can't say, well, I don't have to think about it, she's the specialist. Yes, you do. And not only that, the range of things that you have to think about, and this was particularly true this week, the range of things that you have to think about goes way, way beyond the traditional boundaries of engineering. You think about environmental impact. You think about unintended social consequences. You think about the downstream disposal of what you built or recycling of what you built. So the boundaries of what an engineer does are essentially the boundaries of the globe and humanity. So if you notice that this week, remember it because it's going to turn out to be